The change of base formula tells us that the log of some random base of x equals the log of some base that we choose of x over the log of that base we chose of a. So notice where the x's and a's are here. In this video, we are going to prove it. So once again, the change of base formula tells us that the log of base of some random number of x equals the log with the base that we choose. So let's choose base 10. We don't need to write the 10 when we choose base 10, because that's the common log of x, the number that's a little bit raised up compared to the other letter, over the log of that same base from up here, so base 10 of a. You can put these in parentheses if you want. And this change of base formula is handy when you need to calculate a log that doesn't have base e or base 10, and you only have a scientific calculator that has base 10 and base e buttons. In particular, it can help us solve exponential equations, for instance here. So let's rewrite this with logarithms. So this is log base 5, so the bases are the same. This is base 5 and this is base 5 of the argument here, equals the exponent. Remember, the log equals the exponent. Now here we have this random base 5, and a lot of scientific calculators don't have a log base 5 button. So let's rewrite this with the change of base formula. Let's see, I'll just switch over here. So x equals the log base 10 of 261. That's the common log, over the log base 10 of 5. So I want log base 10 of 261 over log base 10 of 5. And we are at the answer, so let's go ahead and round to 2 decimal places. That would be 3.46. So we just figured out that 5 to the power of 3.46 is about equal to 261. Now, while we were solving this equation, we used the change of base formula. Now, before we get to the main event, there are a couple of things that we need to go over first. And the first one is we need to explain why log base b of b to the power of mk equals just mk. Now let's think about what log base b of x equals. Well, it equals the exponent that turns b into x. So the log base b of b to the power of mk, that equals the exponent that turns b into b to the mk. Or in other words, it's just saying b to what power equals b to the mk. So to summarize here, log base b of b to the mk power, that just equals m times k. We'll be using that shortly. And once again, before we get to the main event, we need to prove the power rule. And the power rule tells us that the log base b of x to the k power equals k times log base b of x. And that turns out to be a pretty handy rule sometimes. All right, now, sometimes when we're proving things, we need a little creativity at the beginning of the proof. So here's how this proof starts. We are going to let m, some random letter m, equal log base b of x. Now, we can rewrite this here And remember, the log equals the exponents. When we rewrite this, this is b to the power of m equals x. It's going to be a little handier here in a moment to keep the x on the left. So I just rewrote this equation using exponents instead of logs. Now I'm going to raise both sides of this equation to the power of k. And using our exponent rules, we can simplify that and get rid of these parentheses. So we have x to the k equal to b to the power of mk. And now remember, we're trying to prove this statement up here. So I'm going to reintroduce logs by taking the log base b of both sides. So I have log base b of x to the k. And that equals log base b of b to the mk. Now, remember we talked about this expression here a few moments ago. Log base b of b to the mk is just saying, well, b raised to what power equals b to the mk power. So this left side equals m times k, or mk. Now this m. That was that letter we just kind of picked out of nowhere, and we said that it equals log base b of x. So I'm going to reintroduce this log base b of x, or substitute it back in for m, because this equals m. So I have log base b of x to the k is equal to log base b of x times k. Now, k is not part of the log at this point. And so we've done it. Let me rewrite this so it's in the order we want it. We have log base b of x to the k. Turns out that that equals k times log base b of x. This rule, it turns out, is pretty handy sometimes. For instance, when we're proving the change of base formula. Okay, so we're trying to prove that the log of base a, just some random base, of x is equal to log base b, a number that we choose, of x over log of the base b of a. All right, well, we're going to start by just kind of, this is where the creativity is, we're going to say that log base a of x equals y. Just kind of a starting place, because we can take this starting place and end up here. So we're trying to get to this equation here from this. I'm going to rewrite this using exponents. So that would be a to the power of y equals x. Remember, the log equals the exponent, so the y is actually the exponent. Now I'm going to take the log base b of both sides. So let's see, we've got the log base b of a to the y equals the log base b of x. That's a b there. Now we're going to use that log property that we just proved that says that log base b of a to the y, that equals y times log base b of a. Now solving this for y, I'm going to divide both sides by log base b of a. Those logs cancel there. And we end up with y equals log base b of x over log base b of a. Well, this is looking pretty good here on the right side. Now, remember what y equals. At the beginning of the proof, we said that y equals log base a of x. That's just how we defined y. So I'm going to substitute log base a of x for y. So I have log base a of x is equal to log base b, some number we choose, of x over log base b of a. That's a b. And we have just proved the change of base formula. So now we can use the change of base formula knowing that we can prove it. I hope this proof of the change of base formula has been helpful. This is Mr. Ela, signing off.